Hello everyone, in this video we're going to verify this identity, and this time let's go ahead and start on the right side and work our way to the left side. It's usually easier to work with squares, so let's try that. So we have proof. We'll start by writing the right side exactly as it appears without any modification. Cosecant of theta minus cotangent of theta squared. So I'm going to go ahead and use this identity from algebra for the square of a difference. We know that it's the first squared minus 2 times the first times the last plus the last squared. So we end up with cosecant squared theta minus 2 cosecant theta cotangent theta plus cotangent squared theta. Now, if we recall, we can go ahead and write the cosecant squared as 1 over sine squared theta minus 2. We'll go ahead and convert everything to sines and cosines. So instead of cosecant theta, we'll go ahead and write times 1 over sine theta. Instead of cotangent, we'll go ahead and write cosine theta over sine theta. Finally, the cotangent squared theta we'll go ahead and write as cosine squared theta over sine squared theta. So now as we continue to simplify, we'll get 1 over sine squared theta minus 2 cosine theta over sine squared theta plus cosine squared theta over sine squared theta. So we notice that 3 like terms turned up for us, which is nice because we can go ahead and combine those fractions now, and we'll end up with, let me just make that look a little bit nicer, more central. Okay, so we end up with 1 minus 2 cosine theta plus cosine squared theta over sine squared theta. Now, you have to keep in mind where you're headed, right? So we want to basically see if we can somehow recognize cosines alone in any of these expressions. So we notice here, of course, we can go ahead and use sine squared theta plus cosine squared theta equals 1 to go ahead and replace the sine squared theta with 1 minus cosine squared theta. So now on the top, this is where your algebra is going to have to shine through, because if you recall, the first identity we wrote down from algebra, this actually fits this, but you would have to think from right to left this time. Notice you have cosine squared theta minus 2 times 1 times cosine theta plus 1. So this expression down here is actually 1 minus cosine theta squared. Go ahead and convince yourself of the truth of that. And also, from algebra again, you'll have to recall f squared minus L squared being f plus L times f minus L. So using this difference of squares identity with these two squares, we realize that it can be written as 1 minus, let me rewrite the numerator, and the denominator we can write as 1 plus cosine theta times 1 minus cosine theta. So now we notice that this 1 minus cosine theta down here can cancel with the one of the ones on the top, because remember, this means 1 minus cosine theta times 1 minus cosine theta, so we can just cancel out the 2, and finally we'll end up with the result we're looking for, which is 1 minus cosine theta over 1 plus cosine theta. And now we have finished the proof, so now we can say QED. All right, so that's a pretty nice identity there to prove. Definitely requires strong algebraic skills. So that's why your algebra teacher kept telling you, please learn this material, because you're going to be utilizing it in every math class you take from now on. Algebra and trigonometry itself actually are the very foundational courses, and of course geometry, that you'll be using as you move on to advanced mathematics, including calculus and higher levels. So be safe until our next video.